So what's going on, George, in data?
People's ability to work with data is catching up to their desire. That's a big trend.
It's much more, I mean, we have a point now where many people have access to the information they need, and that wasn't true a few years ago. I think it's changed a lot, and that really is the modern data stack that's made that work, I think. Sometimes people talk about different approaches, and you can always, if you're in Silicon Valley and smart enough, you can try and build these things yourself, but it's really, to me, the modern data stack that's opened up data and made that available, democratized data for companies of all sizes to really use it effectively.
The cloud also, right?
Well, yeah, the cloud is the basis that it was possible. The modern data stack couldn't be created without the cloud, because the modern data stack is really about delivering analytics as a service, being able to achieve cloud scale and the efficiency, the cost efficiency of the cloud. And then in my opinion, the other thing is SQL, using SQL for data modeling. That's really a key to the modern data stack. And if you look across all the vendors, I think everyone's converging into similar solutions. It's good to see how Databricks has really evolved in that. You guys have done a lot, so.
Yeah, so I would say SQL is awesome. We love it. But Python is also on fire. If you look at those two trends, like Python and SQL are on fire, right? And there's like millions of students going out there learning Python, learning programming 4th grade, 5th grade, 3rd grade. So you're going to have all these people that come out that are data literate and they know how to do programming, whether it's Python or SQL, and
and more both. I think people will learn a procedural language like Python, and they'll really get great at that. But they're also calling SQL to actually get their job done, and those two things together are really how the modern data stack is solving the predictive analytics problem.
SQL is interesting because you see a lot of late learners of SQL be very successful with it. You see people who studied something else in college, they probably had a different job for a while, and they cross over to being some kind of analyst, and they can learn SQL pretty readily, and they can use it to solve real problems. And I think that human dimension of it is very important, that it's a little bit, it has a few less sharp edges than, say, Python and other procedural languages, and that creates an open door for a lot of people.
So I'm going to predict the modern data stack in the future will be, the lingua francas will be Python and SQL, like on equal footing, will be supported. And they have pros and cons.
It's funny because they're both deeply flawed for historical reasons, and it's unclear whether the flaws will ever be fixed, and they're not big enough to really stop their momentum. It seems to be the inevitable.
The perfect language is Esperanto, but here we are speaking English.
Yeah, exactly. It's the perfect ones never win.
Exactly.
SQL is imperfect, but it really has solved an incredible amount of problems, and it has become, as we say, the lingua franca of how data is transformed and how it's accessed and queried. And I don't think that's going to change anytime soon. But it's clear to your point that to solve the more complicated analytic problems, SQL is insufficient. And I don't know that it can ever evolve to take on what people are doing with languages like Python. And so we'll have to see. I do believe that relational technologies will continue to evolve. But SQL will have a long-term role. I don't think it will be the only role by any means. And I do think that something new will come eventually. Eventually something will come to replace SQL, and eventually there will be new languages that will supplant Python. And it's not replace, supplant, because these things are not going to go away. They'll be in use for decades and decades.
I don't think SQL will go away.
No, I don't think
it's not going away.
I don't think it will even be supplanted. I think when we're flying starships to Alpha Centauri, there will be SQL databases in there. I think it has that. It's like a chicken and egg problem to ever change these things.
Lake houses.
There'll be a SQL. There'll be a SQL lake house.
There'll be Python and SQL lake house.
It's a database.
Alpha Centauri.
It's a database, no matter how you look at it.
Will starships have lake houses? That is an interesting question.
Of course,
There'll be a lot of data in starships, I can tell you that for sure. And there'll be a lot of data to collect and process. I don't know. I think that SQL will continue to evolve, and I think it's interesting to see with tools like DBT how people have been able to use it in new and different ways. One of the challenges with SQL is composition, though. And I mean, DBT helps with that, but there are some fundamental issues that really make it difficult to use in broader sort of senses, which is why we need to have some, additional languages like Python to work with data.
Yeah, modularizing your code, composition, as you said, testing your code, getting it sort of, not having these massive CTEs, common table expressions that are like just many, many pages. I think Python helps you modularize it and do software engineering. But SQL then is much more democratized and easier to pick up. So I think there's a place for both.
I joke that our analytics team, if they write a query and it has less than 15 CTEs, it's a slow day.
Well, especially the data frame API, I think is the sort of common pattern that you can see across Python and SQL. It's used by most machine learning frameworks like R and so on, right? It's supported in Python with pandas, and it's very close to SQL. So in fact, the way we've done it at Databricks is that the data frame is the core API, and then SQL is a very simple translation layer on top of it. So you can support fully SQL and data frames. So you can use it for machine learning, but then you can also use it for more declarative kind of SQL-like joins and those kind of things.
I used to use R back in my scientist days. R is another funny one. It has a lot of weird things going on in it. It was not really designed by experts in programming languages. Somehow it got this momentum, and to this day, a lot of the best, most well-curated, well-implemented statistics algorithms are in R, not Python.
Correct.
Even though it's kind of awkward and weird and it's hard even to scale R to one machine, forget multiple machines.
But I don't think R is growing strongly now. I think R it's still around and people are still using it, but I don't see that as the language of the future. If Python is the language of today, no question about that. I'm a big fan of a new one called Julia and what Julia can do. It's a modern language that really can make it easier for people to write these programs. So there's evolution happening in the language space, and there's evolution happening in SQL. And it's interesting to see how languages can make programmers both more productive and be much more efficient in the execution of the system. Remember, these languages are old we're dealing with right now. SQL's 40 years old, and Python's how old? It's not that old, but it's darn old.
Python was a language that was discovered.
Thinking back to where we started, the emergence of the modern data stack, I often think that the real sea change event was actually a change in cost. That there was a group of vendors and data warehouses and data storage and data processing frameworks that were dramatically cheaper than the previous generation. They almost sort of broke ranks with the previous generation of vendors and dropped the price by 90%. And that kind of unlocked ELT, and it unlocked all these additional workloads. People didn't end up spending less. They just did more work. It turned out there was 10 times more work that they wanted to do. I wonder whether there might be another one of those. The cost of the fundamental components of these systems has continued to decline over the last really 10 years since what I just described happened. And I wonder if there will be another kind of breaking ranks where we see the cost drop 10x again, and that unleashes a wave of I don't know what.
I think hardware trends are important to pay attention to. Like, as you said, networks got exponentially cheaper, so it enabled these data lakes to become super cheap and easy to write to.
Yeah.
That enabled separation of compute and storage.
Yeah.
Before that, you couldn't separate compute and storage because writing to the data lake would overwhelm the network. So you would have to think about where is the data, where is the compute. You have to co-locate them because otherwise, that's why data warehouses back in the day were in one appliance because you can't move it over the network. You'll crash the whole network. So now it became cheap. So the question is, what's it for? And by the way, Spark, we developed that because price of memory was going down. So we said, hey, we can actually load up all the data set in the memory because it's going to be cheap enough that you can fit it all there. I think these new ARM chips that are coming now, are really, really interesting. They seem to be able to, bend the curve.
I don't know if we'll see an order of magnitude shift like we saw with the cloud coming in, because there were really three things that came together with that. It was the blob storage that was highly durable and very, very cost effective. Networking, as you described, fast networks, and compute on demand. Those three things came together. And I don't know that there's anything like that happening in the infrastructure space right now. What we're seeing is the costs go down. And that will continue to happen. And the other thing I think we'll see, and we've seen this to an extent, is as the products are getting better, the algorithms are getting better.
Yep.
So it's more of a gradual progression. But as the products simplify, I think the barrier now may not be cost, it's complexity still. And as the complexity barriers are reduced, that's when I think we'll start to see the next set of customers be able to come online and take advantage of it. But the good news is we're seeing customers across the entire spectrum, from really small customers to some of the largest enterprises in the world, really taking advantage of all of the things that the modern data stack delivers.
So you think that what we need is not a 10x reduction in cost at this point. It's cheap enough. We need a 10x improvement in usability.
Yeah. I agree with that, actually.
I think that what we'll see is continued improvement in algorithms, continued improvement in simplicity, simplified deployment patterns, and clarity across the industry as to how this works. And I think all of that happens with the modern data stack. The modern data stack is the thing that's bringing everything together.
But it needs to be further simplified, to your point. I mean, today, the data stack in general is complicated. You know, you kind of need 5 vendors or maybe 10 vendors, and there's competitors to each of them that you have to stitch together to even get the basics up and running, right? Matt Turk has this, like, the data space graph that becomes, more and more pixels every year.
If you look closely at that graph, a lot of vendors appear multiple times, though. There's not actually as many on there.
So it's actually really simple, huh?
It's not simple, but we are seeing a number of platforms emerge that can be used by customers, whether they want to run on AWS or on Azure or on GCP. They have choices, both from the vendor itself and from companies like Databricks and Snowflake. And we have products like Fivetran that are really making it a lot easier for people to get data in there. The biggest challenge I see right now, and the complexity people have, is around governance of these systems. And that's a mess. And there's a tremendous opportunity to improve that. And I think we will see that improvement in the next 3 to 5 years. That's where we'll see tremendous innovation, new kinds of systems emerging.
Yeah, there's so much variety of different data types. And most governance solutions are sort of expecting you to be exactly this way. You need to be exactly in this box. And as long as you're in this box, we can do governance really, really well. Or if you're in that box. So it's making it really complicated for enterprises, I think, to figure out the governance of all their unstructured data, their semi-structured data, their structured data, the data that sits in the machine learning models.
Operational systems, analytic systems. Yeah, the complexity. Yeah. And the thing to realize is that governance needs a revolution equivalent to the cloud and the modern data stack. There's governance products that have been around for a while, that were built really not in the pre-modern data stack era. And then there are pieces and parts that are being put together by different vendors in the modern data stack space. And I think we'll see that converge and become much more holistic and much better clarified and easier for customers to actually construct and use. And I think we'll see that in the next 2 years. That's the next big challenge. We solved the problems of working with gigantic data sets and thousands of users. That was the obstacle forever. That obstacle is solved. Now it's how do you manage this and deal with the new data estate that corporations are building.
Yeah, I think it's happening. And lots of vendors are working on it actively. And they have interesting solutions in the space of governance that I think we'll see come to fruition in the next few years. I agree with you.
What do you think a good governance solution looks like? Is it a product that connects to all the systems and gives you that bird's eye view, sort of a Datadog for governance, or something else?
Well, that's certainly part of it. The idea of understanding your data and being able to understand that the business rules are all correct and that everything is modeled correctly. Those are all parts of it. So, but there's multiple layers to it. One of the biggest parts is really enforcement and dealing and having clarity of how you do tokenization, how you establish rights access, and having that consistent across the organization. And that's challenging right now. It's really challenging to do rights access management across an entire data estate.
There's another aspect of governance which is a little bit less obvious, which is change management. We had a customer here yesterday, Jesse Peterson from Autodesk, talk about how one of the challenges when you start to use all this data and you start to do great things with it, you build products and applications that people all over the company are using. Now, whatever is the original source of that data, whoever's managing that needs to understand they need to think about change management.
Right.
If they change that custom field, they might break God knows what somewhere else. And this is something engineering teams have been dealing with for a long time, but Salesforce admins and Workday admins and analytics teams, it's a little bit new for them. We've seen this at Fivetran, and at Autodesk, they've seen a ton of this as well. It's partly a cultural shift, and then partly, I think, also a tool shift where you have to somehow make people aware of these dependencies that have been introduced by all this cool stuff we're doing with data. It's not all roses. You create some problems as well.
Well, I think you need testing for this. You need, just like for software engineering, we've solved this. We have tests that run and tell us, okay, this is ready to ship. You'll need to have the testing infrastructure for your data and for your data pipelines and all of it. So you would say, oh, I'm going to make this change in Workday right now. Well, does it pass all the tests for all of our systems? Because yeah, it's great for Workday, but you just broke something downstream.
And a lot of people administering these systems, though, that's not even part of their workflow right now. The idea of doing an end-to-end test that covers other systems outside the one they're administering is a new idea to them.
It's even worse than that because they don't know what they're impacting. And there is an example where it's a lack of functionality. When we have systems that track lineage and the history of data, at least there'll be an understanding of the potential impacts downstream. And today, very few customers have access to that information. So they're flying blind. And that's one of the challenges that has to be addressed by the industry.
Mm-hmm.
Lineage is hard.
You have to trace lineage all the way back to the application.
Right, to the operational system. Mm-hmm. And so then through all of the transformations.
So the governance, you said, having a way where you can actually govern your data. Yeah, one is the security operational aspect, like, is this secure? But then there's the discovery, as you said, like, discovering where is the data, how are things connected, what is the lineage of them, being able to track that.
And this becomes much more important as we start to see predictive data apps emerge. Yeah. And that's really what I think people want to build today. They want to take all of the data they have in their data lake, data warehouse, and be able to leverage that, not just to teach their people and get insights for people, but to begin to build applications that allow organizations to be data smart. And really a data app is something that autonomously takes action based on data. And more that those actions have to then be fed into the applications that people use, like Salesforce as well. So the whole thing is a circle, really. And right now, the pieces are coming together from the perspective of the data being traced and the applications being built. Tools like Python are very effective with that. I think the challenge is going to be that these things become more business critical. And so the management and governance of it just becomes all the more important.
Yeah.
We have a project along those lines right now, predicting our revenue each month. So right now we have a very simple system that just does kind of linear extrapolation that predicts our revenue, and it becomes accurate about halfway through the month. And so there's this process that happens every month where everyone nervously watches from about day 7 to day 14 as the estimate dials in. Is this going to be a good month? And in principle, it's possible to do much better than that. We should be able to, with an hour of data at the beginning of the month, have a pretty confident estimate of what it will be at the end. But it's more complicated than a SQL query.
And then we need the data app that tells our sales team exactly what calls to make to go make their numbers, right? That's
yeah. Well, that would be even better.
But that's what we need to build. I mean, and we should be able to build that. I think that with the tools that are at our disposal, we can move in that direction.
Okay, so not to tout my own horn, but so at Databricks we use Databricks for everything. So Databricks on Databricks. So our revenue is predicted using machine learning, and it used to be a tussle between the FP&A teams in finance who would use Excel to predict the revenue and use linear models and whatnot. Until more recently, the machine learning teams basically beat and it's like they got it down to. In fact, recently I was having a meeting with the machine learning teams and I had some ideas of like, hey, we should try this. You can improve it. And they said, yeah, well, we haven't done that. And I said, oh, you haven't? I came up with that idea. So no, we got down below 1% of accuracy and we stopped making it any better. So, I do think the real business value for these enterprises will come once they start be able to do machine learning on all of this data, predictions. And it's hard. There's a lot of challenges with it, but once you can kind of push into that, that's really when you're starting to transform most enterprises.
And then to use that data to predictively take actions and have your organization take actions. Like I say, this idea of understanding which customers need a phone call, maybe because of sentiment that maybe in a recent support experience they had, perhaps their deal is reaching a point where a renewal is possible and they see a potential for an upside. All of those things should be able to be predicted, and action should be able to be taken to affect a change. And that's the future of these data apps. It really is.
Yeah, all SaaS applications will have this kind of intelligence.
Absolutely.
Right?
All SaaS apps will be data apps.
So they don't have that intelligence today. So in some sense, they're unintelligent, right? So in some sense, all software today is to some extent stupid. Like your HR software should tell you who's leaving, who should get promotion, right? Your CRM software should tell you who you should upsell, who is going to churn, should tell you which salespeople should put on which patches, what their quota should be, so on and so forth. Your security software should know all the attacks that are happening in zero time. But we're far away from that. But that's going to happen in the next 10 years. And data and the modern data stack is going to be the foundation of all of that, in my opinion.
And the thing you said that I think is most interesting is that that's data from multiple applications that needs to come together. You've got customer support data, you have sales data, you have finance data. All of those things need to be inputs in. So it can't just be done. It's not like you can do this all in Salesforce. No. Because the answers can't just be found in the sales data. No. They have to be found in other data sets. And that's why the idea of putting it all together in one system supported by the modern data stack is the only way to solve these problems.
Yeah, so consolidation probably will happen in this space because of this, right? Right? Because you mentioned governance earlier and making sure that you can actually get security here into your systems. Well, the security is really hard to do if it's like a security system that's integrating with different apps. So I do think there's going to be data platforms that emerge where the security is built in. They can take all the different data sources from all the different, and they have AI built in so that you can start actually doing this. So probably that's the simplification that's going to happen in this space if we want to move away from Matt Turk's,
I agree. I think this is the history of all software sectors, right? It's unbundling and rebundling, and we're probably at the end of a chapter of unbundling, and rebundling is going to be happening over the next 10 years.
You just bundled.
We just did one small bundling, and it may not be the last one.
Any lessons from that? What's the
integrating an acquisition? I think is easier when it's so important that everyone in the company is focused on it. If it becomes hard enough, it starts to actually become a little bit easier.
Got it.
Yeah. In this case, for Fivetran, bringing HVR in allows us to really take on enterprise scenarios that were much more difficult for us to handle. Support for really high volume data connectors allows us to really solve the toughest problems that customers have. And that gives us the right, if we do that correctly and can do that for our customers, that hopefully will allow us to solve all of the other problems they have.
Well, yeah, Fivetran HVR was just a great match. I mean, the two companies had inverse weaknesses, so we really filled in each other's gaps in a really neat way. So it was a rare opportunity.
We're very excited about it. Integrating with, so you can get your CDC from the HVR side and also get all the SaaS applications into our lakehouse. We're super excited about that.
It's kind of the old world and the new world, and you need both.
Yeah, you need both.
in your central data repository. You need to have both. The old world's not going away. It needs to be brought along.
Those Oracle databases are pretty important.
They're not going anywhere.
Question,
That's
they're
right.
Pretty
That's
important.
right.
And you got to do an incredible job of it. And so it's great that we have the technology now to make that happen for our customers.
That's the real question is, when we're flying that Starship to Alpha Centauri, will it have an Oracle database on it? Larry Ellison would say yes.
An Oracle MySQL database?